Migrating your client applications from Apache Kafka or AWS MSK to the data streaming platform that is Confluent Cloud can be, let's face it, a pretty daunting task. But what if it was really as simple as copy, paste? Hi, I'm Sandon Jacobs, developer advocate at Confluent, and I'm here to talk you through just the tool to simplify this process of migrating to Confluent Cloud. It's as simple as KCP. So let's get into it. KCP is an open source CLI tool from Confluent to help orchestrate your entire migration workflow. KCP distills migration into 4 steps. This all starts with discovery and planning, where KCP scans your existing Kafka deployment to inventory your clusters, topics, schemas, connectors, access control lists, and active Kafka clients. It also generates reports about costs and metrics to better inform your migration plan. Next, we provision the new Confluent Cloud infrastructure, and in this step, KCP generates Terraform configurations for your new CC environment. This includes networking bits like AWS Private Link, VPC peering, and Transit Gateway, along with Kafka cluster linking. This sets the stage for data migration. With our infrastructure in place, we can replicate topic data over cluster linking and migrate ACLs, schemas, and connectors using KCP-generated Terraform code paired with other migration utilities. Finally, with our data flowing to CC, it's time to migrate client applications. Now, this is where many migration efforts go to die because of a number of, well, let's just call them points of contention. For starters, there's the effort of making the changes to client applications with zero downtime across multiple application teams. Now, if that sounds like an exercise in herding cats, it's because client applications are often owned by different teams, and each one of those teams has their own release life cycles, they have their own development priorities, and risk tolerance. Trying to orchestrate a big bang cutover is a project management nightmare. While it might make for a busy, colorful Gantt chart, that's where the fun ends. Next, there's authentication. Your source cluster probably uses a different authentication mechanism than your destination cluster in Confluent Cloud. Updating every client auth's configuration is tedious and error-prone. Then there's managing consumer offsets. We need to ensure that our migrated consumer applications don't reprocess or skip events. Last but not least is risk. What do we do if or when something goes sideways? You need a reliable way to roll back without data loss or corruption. And by that, I mean something other than a migration plan docked with an untested concept of a rollback plan. These concerns leave us with some not so tasty options. We could schedule planned downtime. That sounds like a weekend love fest with your coworkers locked into your office powered by caffeine and junk food. Or we could saddle developers with creating some complex dual producer setup. That's just tech debt, not to mention the complexity of ACID transactions. Well, neither of these sounds like ideal options to me. So let's see how KCP can help. KCP leverages a couple of components to make your client migration as seamless as possible. Cluster linking enables you to directly connect clusters and mirror topics from one cluster to another with byte-for-byte replication. These mirrored topics maintain globally consistent offsets and identical content across partitions. Cluster linking is secure, high performance, and tolerant to network latency. It's also built into Confluent Server and Confluent Cloud, making it easy to build multi-data-center, multi-region, and hybrid cloud deployments. Let's start with Kafka external cluster linking over AWS Private Link. We can securely replicate data from MSK or Apache Kafka clusters in AWS without exposing that data to the open internet. This includes topic data and consumer offsets. Next is Confluent Cloud Gateway, a cloud-native proxy for Apache Kafka that acts as an intelligent router between your client applications and Kafka clusters. When a Kafka protocol client uses a CC Gateway endpoint as its bootstrap server, that request is securely routed to the appropriate Kafka cluster. Here's how it's done. In CC Gateway, we'll configure 2 streaming domains, one for the existing MSK cluster and another for the newly provisioned Confluent Cloud environment. With this setup, CC Gateway is ready, but no clients are using it just yet. KCP introduces a concept called migration groups. This is a logical collection of Kafka topics and related client applications that operate as a unit. Members of a group need to migrate together to ensure we can continue to serve and process data in a business-as-usual fashion. For example, KCP discovers a payments group that has topics like payment transactions and payment events. and the client applications that use those topics. Later, we'll have KCP commands that can operate at this migration group level, and that'll help us avoid the big bang migration scenario that we've been talking about. Once these groups are defined, we can start onboarding clients to use CC Gateway. For each group, we define a gateway route, and each route has its own bootstrap endpoint. Operators share that bootstrap endpoint with the team that manages the group so they can update the configuration of the client applications. This means the application is no longer connected directly to the existing source cluster, but now to the gateway. This means teams are free to migrate the groups they're responsible for on their own schedule. CC Gateway is proxying traffic for these client applications to the source cluster, and that sets the stage for a transparent cutover for that migration group. With these gateway routes in place, we're only a few KCP commands away from migrating a group of producers and consumers to the new destination cluster in Confluent Cloud. Because of CC Gateway and cluster linking, there's no partial state for that migration group. For consumers, the offsets have been replicating in Confluent Cloud this whole time. So the consumers can pick up in CC exactly where they left off in MSK. In our testing, this is a very short migration window. We're talking less than 30 seconds, where consumers experience zero effective downtime. And your Kafka producers operate just as they were designed. They're buffering during this window until the traffic in CC Gateway is unblocked. And those pending writes will then succeed onto Confluent Cloud. Now let's have a word about authentication. And this is where Confluent Cloud Gateway really shines, because it can accept client connections authenticated with one mechanism and translate those credentials to a different mechanism as it forwards the request to the destination cluster. For example, let's say your clients authenticate to Kafka using username and password. Confluent Cloud uses API keys provisioned by KCP. Without CC Gateway, every client app would need to update its configuration. That takes us back to that cat herding scenario we talked about before, remember? Instead, CC Gateway allows clients to keep their existing credentials. It extracts the client's identity and looks up the credentials from a supported secret store. Think AWS Secrets Manager or HashiCorp Vault. Then it uses those credentials to authenticate to the destination cluster. Here are some supported translation paths. This means there's no need for immediate changes to client configurations by developers for authentication. Gateway is going to handle this authentication mapping for us. So what's next? Currently, KCP migrates all traffic for a migration group. Work has already started on a traffic plane-aware migration strategy. This means you could independently migrate consumers or producers in a migration group. There are also plans for KCP and CC Gateway to enable more granular principle and topic-based migrations. This would make for more precise control of the migration flow and go even further to help mitigate risk and side effects. And that's how you conquer Kafka client migrations to Confluent Cloud using KCP. We've tackled a workflow that was once measured in days, weeks, or even months, and streamlined the process to a handful of commands. With minimal development effort, you can migrate Kafka clients to Confluent Cloud on your schedule. KCP is an open source project under the Apache 2.0 license. We'll provide a link to the GitHub repo along with other useful resources on KCP and Confluent Cloud Gateway in the description. We also have a hands-on guided workshop so you can try this migration for yourself. Remember to subscribe to Confluent Developer on YouTube and visit developer.confluent.io, your go-to source for all things in the data streaming space. Thanks for watching.